My presentation is on how a universal remote control works. Before I get into the nuts and bolts of how a remote control works, I just wanted to give you a little history. So Robert Adler is the man who's known as pioneering the remote control. Adler, who held a PhD in physics, was born and educated in Austria. After he emigrated to the United States, he worked for Zenith Electronics Corporation. In 1950, Zenith produced the first TV remote control called the Lazy Bones, which performed some basic TV functions like turning the TV on and off and changing the channel, but it was a little bit inconvenient because it was attached to the TV by a cord. In 1955, Zenith then produced a wireless remote called the Flashmatic. The Flashmatic basically operated like a flashlight and was pointed at photocells located in the corners of the TV cabinet. The problem with that was that the photocells also reacted to sunlight. Adler solved the Flashmatic problem by creating a device that communicated with a TV with sound rather than by light. So the first remote control that he created actually used ultrasound, which has frequencies higher than the human ear can hear, to communicate with a television set. Now today, we've actually moved away from sound and back to light in remote controls. Infrared technology is what's predominantly used in universal remote controls or just TV remote controls in general. Infrared remote controls use light to carry signals between the remote and the device that's being directed. Infrared light is invisible, or is on the invisible portion of the electromagnetic spectrum, so it avoids the problems of the earlier Flashmatic, which was interfered with visible light. Universal remote controls can control a wide array of electronic devices, including but not limited to DVD players, VCRs, CD changers, Laserdisc players, amplifiers, tape decks, if anybody has those anymore, game consoles, computers, light controllers, climate controllers, cable boxes, and satellite boxes. Now let's talk about how a remote works. An infrared remote control sends out pulses of infrared light that represent specific binary codes. The binary codes correspond to various commands, such as turning the TV on and off, turning up the volume, changing the channel, etc. The infrared receiver in the television or the stereo or any other device that you're using will decode the pulses of light into binary data, and that device's microprocessor will then perform the command based on that information. Now this slide pictures an example of remote control codes used in the Sony Control-S protocol, which is a 7-bit binary command system. Now, generally speaking, when you push a button on a remote control, the button touches the contact beneath it to complete the circuit for the selected function on the circuit board. A function like turning up the volume. After the button is pushed, this sends an electrical impulse to the integrated circuit. The integrated circuit is where the binary codes are stored. The integrated circuit then sends the binary command to the LED at the front of the remote. The LED then sends out a series of light pulses to the receiver on the device, and those light pulses correspond to a certain binary command. Once the infrared receiver on the device picks up the signal from the remote and verifies from the binary code that it's supposed to carry out a particular command, it then converts the light pulses back into the electrical signal for the binary code associated with the command. For example, turning up the volume. Then it passes the signal to the microprocessor, which then carries out the command on the device. Along with a desired function, a remote control also transmits other data. The remote control has to transmit the code for the device that it's controlling in order to notify the receiver on that device that the signal is in fact intended for that device. That's how, for instance, you might have a remote that controls your TV but wouldn't turn on your stereo because they send out different signals, and the TV understands that signal is for the TV, and the radio, is not receiving that signal because it's not intended for the radio. Now, after the function is carried out, the function data is usually capped by a stop command, so that tells the infrared device to go back into passive mode. So that's why if you push the volume up button, the volume doesn't just keep going up infinitely, it'll stop. Now, in learning universal remote, they come pre-programmed to operate a number of popular electronic models, but they also have the ability to learn functions of the original manufacturer's remote by holding the learning remote head-to-head with the original remote control. And the infrared signals then are transmitted to the learning remote, which duplicates the other remote control's commands. Most of these types of universal remote controls will come with battery backup feature or a charging cradle so that your programmed commands would be saved when you have to change batteries. Now let's take a quick peek inside the remote control. The basic parts involved in sending an infrared signal include buttons, button contacts, which are underneath the buttons, an integrated circuit, and a light emitting diode. Remotes are powered by batteries, which are connected to springs. The power from the battery goes through the springs to the circuit board, and then the circuit boards are typically made of fiberglass with a thin layer of copper on the back. The copper, which is a conductor, acts like a wire, and the spaces between the copper act like an insulator so that there are no short circuits. The copper connection allows for a current to flow and send signals to the integrated circuit. Now, infrared receivers sit on the front of a device so that they can easily receive the signal from the remote control. Now, I'm sure we've all had the experience where, you've had to kind of play around with the direction or angle you're pointing a remote to get, your TV to turn on, for instance. And that has to do with the strength of the signal coming from the remote. A remote with more than one LED or a particularly powerful LED produces a stronger, broader signal, which allows a remote to work even when not directly pointing at an infrared receiver. That concludes this presentation. Hopefully you've learned a little bit more about how universal remote control works.